Monitoring of Electronic Image Display Systems, Part 2. Let's take a moment to look at some specific luminance and contrast tests. Maximum luminance is simply checked at the same monitor over time using a photometer. New LCDs have self-correcting capabilities and only need to be checked once a year. Luminance response refers to the monitor's ability to accurately display different shades of brightness, much like a contrast test. Using the SMPTE test pattern, there's a ring of squares near the center. The two 50% squares at the top of this ring should match. At the bottom of the ring, there are two sets of squares marked 0% 5% and 95% 100%. You should be able to distinguish the 95% white square embedded with the 100% white square, as well as the 5% brightness square embedded within the 0% or black square. DICOM standards include a grayscale standard display function, or GSDF. This ring of density squares in 10% increments from white to black creates a ramp of brightness that should be measurable with a photometer and should fall within 10% variation of AAPM standards. Another contrast-related test is called the luminance ratio. It compares the maximum luminance to the minimum luminance value. It can be measured in the black and white bars located above and below the ring of 10% variable density squares. And finally, luminance uniformity refers to the consistency of a single brightness level displayed across the area of the screen. This can be measured at each of the four corners of the SMPTE pattern, as well as the center, and should not deviate more than 30% from their average. There are two kinds of reflection or reflectance coming off the surface of a monitor screen. Diffuse reflectance is the ratio of the brightness of the general ambient light in the room that is being reflected off the surface of the screen to the output brightness of the display monitor itself. This is measured by the physicist using fluorescent lights set up behind the monitor which flood the room with diffuse light. Specular reflectance refers to the reflection of a specific, localized light source within the room, such as a light bulb, placed behind the person viewing the display monitor. It is defined as the ratio of reflected brightness to the brightness of that light source. These are both important because ambient lighting in the room must be dimmed to a point where both types of reflectance are below any noticeable level that would impede full visibility of the image. As your textbook states, there are no quantified guidelines for acceptable levels of noise in the electronic radiographic images yet. The AAPM made a test pattern available for monitoring noise levels over time, consisting of a series of circular areas within a black mask which gradually increase in brightness as they progress diagonally across a small square section of the screen. Unfortunately, I was unable to download the template for the specific test, but I imagine it to be similar to this image. The suggested passing point is that in at least 3 quadrants of the screen, the majority of the square sections demonstrate the dimmest dot. Both the ACR and AAPM recommend minimum resolution for electronically displayed images of 2.5 line pairs per millimeter. The generic SMPTE pattern has a series of high contrast and low contrast bars of diminishing widths to check resolution. In all resolution tests, the observer inspects the bar images for blurring or bleeding of each white or black bar into the adjacent bars at the edges. The image here is the AAPM's version of a test pattern, the TG18, that consists of the line pair per millimeter test bars at the corners, as well as the CX patterns, each consisting of a squared C with an X inside of it across the screen. By visually matching these with a set of larger CX patterns that have been progressively blurred, the resolution can be determined off a correlating table. The screen is divided into 12 areas, and a passing score is attained when 4 or fewer of these do not meet the minimum resolution standard.